According to the National Electrical Code, it is acceptable to tap from a 20 amp THHN 12 lighting circuit a 2-wire THHN 14 branch for the switches when the light load for that switch will only be from 60 watts up to 300 watts maximum. The National Electrical Code sets the standard for safe electrical installations, and understanding its rules is crucial for any electrical work. It's important to examine the specific requirements for switch installations to ensure compliance and safety. The NEC mandates that the switch be rated for the load it will be controlling, the switch must be installed in an accessible box, and the switch be wired in accordance with the NEC. Each of these points is essential for a safe and functional installation. Considering a scenario where a switch controls a light load between 60 watts and 300 watts, it falls within the rating of a 15 amp switch. This means the switch is adequately sized to handle the electrical demand without being overloaded. The accessibility of the switch's junction box is another key requirement. This ensures that the switch and its connections can be easily inspected and maintained, which is important for troubleshooting or repairs. Proper wiring according to the NEC is fundamental. This involves using the correct wire gauge, making secure connections, and following the code's guidelines for running and protecting the wires. Given these considerations, tapping from a 20 amp THHN 12 lighting circuit with a 2-wire THHN 14 branch for the switches is acceptable, provided that the light load remains within the specified range of 60 watts to 300 watts. The National Electrical Code allows for this practice because the smaller gauge wire is still capable of safely carrying the current required by the lighting load. However, it's crucial to emphasize that all connections must be made properly and safely following NEC guidelines. In general, NEC 14 AWG wire is rated for 15 amps and NEC 12 AWG wire is rated for 20 amps. This refers to the maximum current carrying capacity or ampacity of the conductors. It is important to know the ampacity of the wiring to prevent overheating, which can lead to insulation damage and fire hazards. The National Electrical Code specifies the allowable ampacities for conductors based on their insulation type, temperature rating, and installation method. For example, THHN insulation is rated for higher temperatures than some other types of insulation, allowing it to carry more current. Understanding these ratings is essential for selecting the right wire size for a given circuit. Branch circuits are classified according to the maximum allowable of a current protection device, such as a circuit breaker or fuse. Common branch circuit ratings include 15 amp, 20 amp, and 30 amp circuits. The rating of the branch circuit determines the maximum load that can be safely connected to it. For a 20 amp branch circuit, the total load should not exceed 80% of the circuit's rating, which is 16 amps. This is done to prevent the circuit from being overloaded. It is common practice to use NEC 12 AWG wire for 20 amp branch circuits and NEC 14 AWG wire for 15 amp branch circuits. This ensures that the wire is capable of safely carrying the maximum current that the circuit is likely to draw. However, as previously discussed, it is permissible to use a smaller gauge wire for a portion of the circuit if the load is relatively small and the requirements of the NEC are met. When tapping a lighting circuit for switches, it is important to consider the total load on the circuit, including the lighting fixtures and any other devices that are connected to it. The total load should not exceed the rating of the circuit breaker or fuse. In addition, it is important to ensure that the switches are rated for the voltage and current that they will be controlling. Switches are typically rated for 120 volts or 277 volts, and for a certain number of amps. The switch rating should be equal to or greater than the voltage and current of the circuit that it is controlling. The National Electrical Code provides detailed requirements for the installation of switches, including the type of box that is required, the method of wiring, and the location of the switch. These requirements are designed to ensure that the switches are installed safely and correctly. In addition to the requirements for switches, the NEC also provides requirements for lighting fixtures. These requirements cover the type of fixture that is allowed, the method of installation, and the location of the fixture. The NEC also requires that all lighting fixtures be properly grounded to prevent electric shock. Grounding provides a low impedance path for fault current to flow back to the source, causing the circuit breaker to trip and de-energize the circuit. This protects people from electrical shock. When working with electrical wiring, it is important to follow all safety precautions. This includes wearing appropriate personal protective equipment, such as safety glasses and gloves. It is also important to turn off the power to the circuit before working on it. This can be done by flipping the circuit breaker to the off position. In addition, it is important to test the circuit to make sure that it is de-energized before touching any of the wires. This can be done using a voltage tester. If you are not comfortable working with electrical wiring, it is best to hire a qualified electrician. Electricians have the training and experience to safely and correctly install and repair electrical wiring. In summary, the National Electrical Code is a comprehensive set of rules that govern the safe installation of electrical wiring. By following these rules, you can help to prevent electrical fires and electric shock. When tapping a lighting circuit for switches, it is important to consider the total load on the circuit, the rating of the switches, and the requirements of the NEC. By following these guidelines, you can ensure that the electrical wiring is safe and compliant. It is always important to consult with a qualified electrician if you have any questions or concerns about electrical wiring. Always remember to prioritize safety when working with electricity. Ensure that the power is turned off before starting any electrical work, and always use appropriate safety gear. If you are unsure about any aspect of the work, consult with a licensed electrician who can provide guidance and ensure that the work is done safely and in accordance with the NEC. When working with electrical circuits, it's crucial to understand the concept of voltage drop. Voltage drop refers to the decrease in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause lights to dim, motors to run inefficiently, and other electrical equipment to malfunction. The NEC recommends limiting voltage drop to a maximum of 3% for branch circuits and 5% for feeders. To minimize voltage drop, it's important to use the correct wire size for the length of the circuit. Longer circuits require larger gauge wires to reduce resistance and voltage drop. There are voltage drop calculators available online that can help you determine the appropriate wire size for a given circuit. Another important consideration when working with electrical circuits is grounding. Grounding provides a low impedance path for fault current to flow back to the source, which helps to protect people from electric shock. The NEC requires that all electrical equipment be properly grounded. There are several different methods of grounding, including equipment grounding conductors, grounding electrodes, and bonding jumpers. It's important to understand the different types of grounding and to use the appropriate method for each application. When working with electrical boxes, it's important to choose the right size box for the number of conductors and devices that will be installed in it. The NEC specifies the minimum box fill requirements, which are based on the volume of the box and the size of the conductors and devices. Overfilling an electrical box can cause overheating and can make it difficult to make proper connections. When making electrical connections, it's important to use the correct type of connector for the application. There are several different types of connectors available, including wire connectors, crimp connectors, and terminal blocks. It's important to choose a connector that is rated for the voltage and current of the circuit. It's also important to make sure that the connections are tight and secure to prevent loose connections, which can cause overheating and arcing. When running electrical wiring, it's important to protect the wiring from physical damage. This can be done by using conduit, cable trays, or other protective measures. The NEC specifies the requirements for protecting electrical wiring in different environments. For example, wiring that is installed in wet locations must be protected by a waterproof enclosure. When installing electrical equipment, it's important to follow the manufacturer's instructions. The manufacturer's instructions will provide information on the proper installation and operation of the equipment. It's also important to check the equipment for any signs of damage before installing it. If you are not comfortable working with electrical wiring, it's best to hire a qualified electrician. Electricians have the training and experience to safely and correctly install and repair electrical wiring. In addition to the NEC, there may be other local codes and regulations that apply to electrical work. It's important to check with your local building department to find out what codes and regulations apply in your area. By following all applicable codes and regulations, you can ensure that your electrical work is safe and compliant. Electrical work can be dangerous, so it's important to take all necessary precautions to protect yourself and others. Always turn off the power before working on electrical circuits, and always use appropriate safety gear. If you are unsure about any aspect of the work, consult with a licensed electrician who can provide guidance and ensure that the work is done safely. Remember that using the correct wire gauge is paramount for safety and compliance. The ampacity of the wire must be sufficient for the load it will carry, and the installation must adhere to the NEC guidelines. Always consult the NEC for the most up-to-date information and requirements. The National Electrical Code Article 210.19 addresses conductor ampacity and size. It states that branch circuit conductors shall have an ampacity not less than the maximum load to be served. For lighting circuits, this means that the conductors must be sized to handle the total lighting load, including any additional loads that may be connected to the circuit. The NEC also specifies the minimum size conductors that are allowed for different branch circuit ratings. For example, a 15 amp branch circuit must have conductors that are at least 14 AWG, and a 20 amp branch circuit must have conductors that are at least 12 AWG. However, as previously discussed, it is permissible to use a smaller gauge wire for a portion of the circuit if the load is relatively small and the requirements of the NEC are met. When determining the correct wire size for a circuit, it is important to consider the ambient temperature. The ampacity of a conductor decreases as the ambient temperature increases. This is because the conductor is less able to dissipate heat at higher temperatures. The NEC provides tables that list the ampacity of conductors at different ambient temperatures. These tables can be used to adjust the ampacity of a conductor based on the ambient temperature. Another factor to consider when determining the correct wire size for a circuit is the number of conductors in a raceway or cable. When multiple conductors are installed in a raceway or cable, the ampacity of each conductor is reduced. This is because the conductors are less able to dissipate heat when they are close together. The NEC provides tables that list the ampacity adjustment factors for different numbers of conductors in a raceway or cable. These tables can be used to adjust the ampacity of a conductor based on the number of conductors in the raceway or cable. In addition to the requirements for conductor ampacity and size, the NEC also provides requirements for overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. The NEC specifies the maximum size overcurrent protection device that is allowed for different branch circuit ratings. For example, a 15 amp branch circuit must have an overcurrent protection device that is rated at 15 amps or less, and a 20 amp branch circuit must have an overcurrent protection device that is rated at 20 amps or less. It is important to choose the correct size overcurrent protection device for a circuit to protect it from overloads and short circuits. Overcurrent protection devices are designed to trip or blow when the current in a circuit exceeds the rating of the device. This interrupts the flow of current and prevents the circuit from overheating and causing a fire. When installing overcurrent protection devices, it is important to follow the manufacturer's instructions. The manufacturer's instructions will provide information on the proper installation and operation of the device. It is also important to check the device for any signs of damage before installing it. Another important aspect of electrical wiring is proper grounding. Grounding provides a low impedance path for fault current to flow back to the source, which helps to protect people from electric shock. The NEC requires that all electrical equipment be properly grounded. There are several different methods of grounding, including equipment grounding conductors, grounding electrodes, and bonding jumpers. It is important to understand the different types of grounding and to use the appropriate method for each application. Equipment grounding conductors are used to connect the non-current carrying metal parts of electrical equipment to the grounding system. This provides a path for fault current to flow back to the source in the event of a ground fault. Grounding electrodes are used to connect the grounding system to the earth. This provides a low impedance path for fault current to flow back to the source in the event of a ground fault. Bonding jumpers are used to connect different parts of the grounding system together. This ensures that all parts of the grounding system are at the same potential, which helps to prevent electric shock. When working with electrical wiring, it is important to follow all safety precautions. This includes wearing appropriate personal protective equipment, such as safety glasses and gloves. It is also important to turn off the power to the circuit before working on it. In conclusion, tapping a 20 amp circuit with no 14 wire for lighting switches is permissible under specific conditions outlined by the NEC, primarily concerning the load and switch ratings. Always prioritize safety, consult the latest NEC guidelines, and engage a qualified electrician when necessary.